Welcome to this tutorial on art, where we will talk about variable inference and model inference. So what I'll do in this tutorial is to talk about the many options under analysis called variable and model inference. Before I use those options, I'd like to show you the data that I will do inference with. The first I'll do is to look at this data in this pure text file that has two columns of data. The first column is supposed to be observed values of some stiffness, some material stiffness, while the second column are the corresponding observed strength values. And I get data into RT. I go to analysis, variable inference. I'm going to look for the file, there it is. And what I'm going to do is that I'm going to look at the cumulative frequency diagram, and I'm going to compare the data with some standard distribution types. So I'm clicking here the log normal and say the log normal just for the demonstration, so that you will see in a moment that I compare the data with those standard distributions. When I press OK, then you'll see several plots. We'll get to the output pane here in a little moment, but first you'll see the scatter plot for the data. So there's some correlation apparently between the stiffness and the strength for these particular data, as you can see from this kind of alignment of the scatter plot. You'll also see these cumulative frequency diagrams where we have the normal and log normal distribution plotted on top of the data. So this may give some sense of what type of distribution would fit the data. And then I'd like to draw your attention to the output pane. So the mean of the data in the first column was this number here, and here's also the standard deviation. If I scroll a little over, you'll see that the coefficient of variation of the first column of data was a little over 7%, while the second column had a lower variability, a lower variance, in the sense that the coefficient of variation is down to 4%. You'll also see the correlation coefficient between those columns of data. I'd also like to show you something else in this tutorial on inference. So I'm going to close the window and delete the output to be ready for something else. Namely, I'd like to have a look at this data here. Let me see what I have in the background. Not here, but this one. These data here shows something else than what the other ones were. It shows the value of the stiffness, observed stiffness, in the first column, but then I have regressors. 1, 2, 3 columns of observed regressor values. So now I'd like to do linear regression with these data in this particular file. So then I go back to RT, I go to analysis, but this time model inference instead of variable inference, because I want to build now a linear regression model. I browse for the file and load it into RT. There are a number of plots that I can add to my inference. I'm going to keep the default option for now. Press OK. So what you see here now is, first of all, in the output pane, you will find the mean and the standard deviation, in fact the coefficient of variation, of the model parameters. There are 3 model parameters because there were 3 observed regressors, and you also find the correlation matrix here in the output. The R factor and the mean of the standard deviation of the model error are also given there. And in the main pane, in the visualization pane I should say, you'll find several plots. You'll find the so-called QQ plot to see if the errors are normal. You'll see how well the observation, or in fact how well the model fit the observations, both in this plot here and in this plot here. And you have the residuals also plotted. I had ticked that off in the dialog box. In fact, that was the default to show these residual plots. So this is how you can do inference in art, and in other tutorials we'll look at how to do reliability analysis with models like these.